Hi, I'm Tony McClelland, Case IH Crop Production Sales Specialist for parts of Illinois and Missouri. Compacted soil reduces the amount of pore space that's in that soil. It's that pore space that allows the soil to hold air and water, so it really reduces the amount of water holding capability of the soil. Compacted soil really hinders root growth. It slows down the ability for roots to proliferate and grow. It also slows down the ability for soil to absorb rainfall and allow nutrients and moisture to move throughout the profile of the soil. All of this adds up to costly yield loss. Today we're going to talk about how we can reduce soil compaction, improve your soil tilth, which will improve your yields and improve your profit potential. Hydraulic compaction is caused when soil is at or near its maximum moisture holding capacity. As that water drains down, it collapses that pore space and causes the compaction. When possible, you should avoid driving or operating equipment on wet soil. Another type of compaction is surface compaction. This is compaction that's in that top 8 to 12 inches of soil. To reduce surface compaction, try to reduce the traffic across your field, either by running wider equipment to reduce the number of passes, or run equipment that can do more in a single pass. Also, your choice of tires and inflation can affect compaction. By choosing tires that are either taller with longer footprints or wider with more footprints, or by lowering the PSI, can help reduce that yield-robbing soil compaction. Just make sure to always follow the manufacturer's guidelines for setting tire inflation based on the load that tire is carrying. Jody DeYoung-Hughes, a regional extension educator in crops and soils from the University of Minnesota Extension, says that axle loads less than 10 tons per axle can keep compaction in that top 6 to 8 inches of soil. She also says that axle loads of the heavy equipment that's used today can cause compaction as far as 3 to 4 feet deep. That's called deep compaction. Deep compaction is one of our greatest concerns because its true adverse impact on yields may not be seen for the first several years. For example, average first-year yield losses due to severe compaction of approximately 15%. That's according to a Pennsylvania State University extension summary of soil compaction studies in different countries. 10 years later, yield losses were reduced to 3% when there wasn't any recompaction in the same study, but the final yield loss was assumed to be a result of subsoil compaction and considered a permanent yield reduction. In a good year, you might not see any impact of the compaction on your yield, but in a bad year, when moisture and soil nutrients are harder for the plant to access, compaction will impact your yield. The Case IH quad track and row track design helps minimize soil compaction. Even weight distribution of the row track and quad track designs helps minimize that ground pressure. That really reduces the amount of compaction that can occur and lets that tractor float across the field, even under full traction and full power as that tractor is pulling a load. Let's take a look at the independent 4-track system on these tractors. Because of the tractor's articulated steering and tri-point oscillation, 26 degrees, the tractor delivers good power and torque to all 4 corners of the tractor. That optimizes its traction and its flotation throughout all kinds of ground conditions, even during turning. Articulated steering of this tractor, in other words, the fact that it bends to steer, allows it to really minimize any berming that can happen on the ends and minimize soil disturbance when it's turning. Also, under heavy loads, because of the 4-track system, it minimizes any weight transfer that affects even under full load. If I compare this to a 2-track tractor system where there's only 2 tracks, as it gets under a heavy load, it transfers weight to the rear part of the tracks, which really you start to lose that ground contact and increases compaction. Also on a 2-track tractor, because of the nature of the bulldozer or skid steer's type of turning, they really tend to throw berms or ridges wherever they turn in the field. Each track actually pivots up and down 10 degrees, which allows it to follow ground contours, and each track does this independently, so all 4 tracks are always at good ground contact all the time. We've actually got 5 pairs of wheels, idler wheels and roller wheels, so there's actually 5 sets of axles giving it good contact to the ground to spread the weight out to minimize soil compaction. As previously mentioned, axle loads of more than 10 tons per axle can contribute to yield-robbing soil compaction as much as 4 feet deep. The Case IH quad track and row track design, by adding more axles, helps reduce that effect of deep soil compaction. For example, let's take a 60-foot field cultivator pulled by a 600 quad track. The tractor weighs 60,000 pounds and has 10 axles. If you divide that 60,000 pounds out over the 10 axles, that's 6,000 pounds, or 3 tons per axle. That's much lower than the recommended amount of 10 tons or less per axle, minimizing your chances of causing deep compaction. Deep compaction will result in permanent yield loss. So to minimize that deep compaction, let's look at reducing traffic across our fields. We can do this a couple ways: by eliminating passes across the field with wider equipment, or by using equipment that does more in a single pass. Let's look back at that Steiger 600 quad track pulling the 60-foot field cultivator, and let's compare it to a wheel tractor with a 710-70 R42 duals also pulling a 60-foot field cultivator. The tracked area for the quad track with 36-inch belts would equal a total of 6 feet because there's 2 tracked rows. The traffic area for the wheel tractor would be 28 inches for each wheel, times 4 because we're using duals, so we have 4 rows. That equals 9.3 feet. For each pass with a 60-foot field cultivator, the quad track puts down 6 feet of traffic area, or 10% of our working width. Compare that to 9.3 feet with a wheeled tractor putting pressure on the ground in that same 60-foot area, which equates to 15.5% traffic area. That's a 5.5% difference. And this doesn't even take into account the lower PSI or ground pressure associated with a wider footprint of the quad track versus a wheeled tractor. Now, what does that mean in terms of yield loss? Based on Iowa State University research, a grower could see 14% more yield loss in traffic areas versus the rest of the field. If we were growing 200 bushels per acre of corn and 14% of that is lost, we'd be losing 28 bushels an acre in the traffic area. If we carry over that 5.5% advantage in a traffic area of a track tractor versus a wheeled tractor, you'd have a 1.5 bushel per acre advantage. 1.5 bushels per acre can add up to a lot of lost profit potential. Ground compaction can also be reduced with wheeled tractors by looking at different tire options that are available. Case IH offers a full variety of tire sizes and types from the factory, such as increased Flexion technology or IF tires, which allow the tire to carry a lower inflation pressure, and with a softer sidewall, that tire actually can reduce the ground pressure or the footprint of the tractor. You can learn more about agronomic design by visiting caseih.com, where you can sign up for informational emails. Also, I'd like to invite you to visit your local Case IH dealer, where you can learn more about the Case IH quad track and road track tractors, as well as other agronomically designed equipment.